programmers! Today we're going to talk about functions and the different ways you can pass arguments to functions. I've got this little function right here that takes an integer and returns an integer. And I can tell it takes an integer because we have fun in parentheses. So the variable name we choose here doesn't matter. We're doing a call by value. We're making a copy of whatever the argument or constant that's being passed into the function is and putting it into this variable right here. In main, I've got another fun just to show you that these are different funs. So I'll initialize my fun variable to 6 and I'm going to pass it into the function increase right here. So at this point, a copy of this value 6 is made and put into this variable right here. So we've got two different variables. The scope of each of these variables is only for their individual functions. Just to prove that these are different variables, different spots in memories, I went ahead and printed the address in memory for each of those variables. So let's talk about what happens. So we start out and we've got fun equal to 6, and then we call our function and that fun is passed in to this fun, which gets updated by 2, and then when we return this fun, it's going to be copied into this variable right here. So this will turn into 8 and we'll print out the new fun level is 8. Now let's take a look at what happens when we print out the address in memory, and then we can really see that these are two different spots in memory. So I copied and pasted the code from the PowerPoint slide into Visual Studio so I can go ahead and run it. And I can see our execution starts in main, we set fun to 6, we go ahead and print out the current value of fun, which is 6, and then I can get the address of this fun variable using that ampersand. And then I see the address is a hexadecimal string. This is where it is in memory. When I call increase and I pass fun into this function, I'm going to get a copy of that into another variable called fun and increase it by 2. Now I've got 8. And then I'll print the value 8 along with the address in memory of this other fun variable, just to show that these two addresses in memory are different. They're different spots in memory. I'll return this fun value, and then we've got our new fun level is 8. So the disadvantage of using call by value is that you're making copies of whatever you're passing into the function. Not a big deal if you're using an integer, but imagine we've got a structure that has 10 or 20 different parts to it, or an object, a class that has 10 or 20 different class members, and you could be dealing with a pretty large object. Making a copy has some overhead. So instead of making a copy, there's another way to pass something into the function, and that is with pointers. We'll just demo with an int, even though the pointer to an int is the same size as an int. So this is just an example of how to use pointers. So if I want to use a pointer and pass in a pointer to that variable, I can have my function deal with the same object instead of making a copy. I need to pass in the address of that variable and then deal with a pointer to an integer instead of just an integer. And anytime I want to access the value to update it or print it, I'm going to need to have this syntax to dereference the pointer, and I can do that with this star. All right, and then we've already got the address of the pointer, and then if I want to return the new value, do something like that. Now this time when I run this, then I'm going to get the same answer for fun is 6 and then 8, but notice that I'm dealing with the same exact address in memory, and that's what we would expect when we're using pointers. And this could be more efficient if you have really large objects. A lot of people don't like the syntax with pointers, the dereferencing the pointers and the passing in the address. So there is another way to handle this in C++, something called references. And I'm going to undo all the syntax for making this a pointer and then show you that the syntax to make it a reference is much, much simpler, and you still get the advantage of not making a copy of the object. So I think I'm back to normal with my passing in a copy of that integer. And now if I want to say, I don't want a copy of the integer, but I want to be referring to that same spot in memory with a different variable name, or in this case I've got the same name, but the scope of this variable is different. So to make this a reference to that integer, I just add this ampersand. So it's a kind of a different use of the ampersand than when we're printing out the address of this. This is to get the same benefit of pointers where you're not making a copy, but you're dealing with the same exact spot in memory. So when I run this, I can see I'm also dealing with the same spot in memory, but the syntax is very clean. The only thing we did to make this a reference is in the parentheses in the parameters to the function, we just have an ampersand to say this is a reference. And this will also work if our name is not fun. If we have a different variable x, this is still going to work the same way. And we'll see it is the same spot in memory. Even though we've got a different variable name, we're still going to be dealing with, in this case, this spot in memory and updating it from 6 to 8. So I hope that makes sense. More in future videos.